Okay, section 7.1 and 7.2, day one notes. Essential question, how do you find the asymptote of an exponential function is by looking at an equation. Parent function for exponential growth function. Function f of x equals b to the x where b is greater than 1. So whenever you have a exponential function and b is greater than 1, you'll have a growth function, which means the graph will rise from left to right. Um, it's the parent function for the family of exponential growth functions. So this is before you do any transformations where you move it up, down, left, right. Um, these graphs, exponential functions have asymptotes where the graph approaches a line but never quite hits it. In this case, if it doesn't move up or down, the asymptote will always be x equals 0 or the x-axis. The domain for all these growth functions, before you use transformations, the domain is always all real numbers, and the range is y is greater than 0. You can see all the lines are bigger than 0. Even though they get close to 0, they never quite hit it. So we'll graph this one quickly without a graphing calculator. We'll do one later with a graphing calculator. If you want to graph these, first thing you want to do is make a table. And I just use -2, -1, 0, 1, and 2. No, those run together. So 3 to the -2, because I plug in -2 for x. It'd be important that for this section that you are strong with negative exponents and know the rules. When you have a negative exponent, what it does is flip it upside down, or makes it the reciprocal, so it makes it 1 over 3 squared, which is 1 over 9. Okay, so I'd put 1 over 9 for -2. Okay, and since I know that, 3 and -1 would be the reciprocal, which would be 1/3. So 1 divided by 3. 3 to the 0, anything to the 0 power is 1, another property you need to have mastered. 3 to the first is 3, and 3 squared is 9. Okay, so I'm going to plot those dots. -2, -2 1/9 would be very close to 0. -1 1/3 will be a little bit above that, but not much. 0 1 will be right here. 1 3 and 2 9. And then just make it as smooth as you can. Okay, so that's the graph. And then state the domain and range. Just like the note said, domain will always be all real numbers for exponential functions. Okay, and the range in this case is y is greater than 0. Okay, and when it says state the asymptote, you can see the asymptote is right here, because the line gets infinitely close to 0, but it never quite crosses it. Okay, it goes down but never quite crosses it. So the asymptote will be x equals 0, and that's all you need to put. So you need the graph, you get points for the graph, you get points for the domain and range, and you get points for the asymptote, which is x equals 0. Okay, where it approaches but doesn't cross. Okay, on this one, just to show you that you don't have to do it all paper, pencil, or in your head, you can use a graphing calculator. So I'm going to use a graphing calculator real quick. I'm going to do large screen. Let's do large screen. Okay, so I'm actually going to go back and clear this out and plug it in. Okay, so it was what? 1/2 parentheses 4 to the x. So parentheses 1 divided by 2 parentheses 4 to the power of x. Okay, and then you hit graph. You can see what the graph is supposed to look like. Okay, and then if we hit second table, and we can see usually the points we want to use is -2, -1, 0, 1, 2. So we could plug those in for that table and solve it. So you can also do this in your graphing calculator. If you have something different than the TI-84 and you need help with this, that's fine. But that's pretty much how you would plug it in and solve it. Okay, Let me take off this. Never mind. Okay, so let's plug those points in real quick. So we got x, y, and we have -2, -1, 0, 1, and 2. We have 0.03125. We have, what was the other one? I can't remember. It was 0.125. And then we had 1/2 or 0.5. Then we had 2, and we had 8. Okay, so if we're going to graph those, we got -2.03125, -1.125, 0.5 be right in the middle. We got 1, 2, and we have 2, 8. Just make a smooth line connecting them best you can. Okay, and then a line getting infinitely close to that. Okay. The domain will be same, all real numbers, nothing changes on that. You know, you can have positive, negative, 0. The range stays the same, as y is greater than 0, and the asymptote would still just be x equals 0 because it approaches that x-axis, approaches x equals 0, but it never crosses it. So that would be the line for the asymptote. Okay. If it is decay, then B, the only difference between growth and decay, well, a lot of differences. The first difference is B will be between 0 and 1, which makes it decay. So 1/2, 3/4, 0.65, whatever. If it's between 0 and 1, then you're going to have decay where it starts really big and it ends up really small. Okay. That's the main difference. The asymptote doesn't change, the domain doesn't change, the range doesn't change. Just the shape of the graph changes and how you look at it. So you start really big and you end up really small. So let's graph this real quick. Okay. You can do this with the graphing calculator, or you can do it with or you could do it just in your head, whatever's easiest for you. Okay, so you have 1/4 to the -2. Remember, what negative exponent does is it flips it. So 1/4 to the -2 would actually be, you flip it upside down, 4/1, or just 4 squared to make it positive, which is 16. So you can put that in your calculator check. So -2, 16, 1/4 to the -1 would just be the reciprocal, which is 4. 1/4 to the 0, anything to the 0 power is just 1. 1/4 to the first power would just be 1/4. And 1/4 squared would equal 1/16. Okay, so you can see from there, -2, 16 is going to be off the graph. -1/4, 1, 2, 3, 4, be right here. 0, 1, you have 1 and 1/4, and you have 1 and 1/16. Okay, so you can see that instead of rising from left to right, now it falls from left to right. And that's because 1/4 is in between 0 and 1. Okay, and that's what makes it have decay. So domain doesn't change. Domain is all real numbers. The range doesn't change. It's still y is greater than 0, even though it goes the opposite way. And the asymptote is still x equals 0. Still have that dashed line. Oops. Let's do another one. Okay, you still have that dashed line where it approaches x equals 0, the x-axis, but never quite crosses it. Okay, so that's decay. Okay, still 2/5, so you should know right now it's going to be decay because 2/5 is less than 1. Whatever the base is, the number with the exponent, it determines whether it's going to be growth or decay. All right, so this one I'm going to use graphing calculator again. Let's clear this out. Let's go back to y equals. And maybe if you want, well, let's clear key history. So let's clear this out. If you need help with the keys, let's do this. It might not be as big, but that's okay. So then we're going to go, what was the graph? Okay, it was -3 parentheses 2 divided by 5 to the power of x. Then we're going to hit graph. I know you can't see all the keystrokes, but those are the keystrokes right there if you need to see them. And notice how this graph looks different than the other ones. Well, no matter the function, if you have that negative out in front, what it does is it flex across the x-axis. So normally it would look like this, but since the negative flips upside down, it looks like this. Okay, so that's what a negative does, but it's still a decay function. It just reflected over the x-axis. So if we want to use some points for x and y, we can use those. We have -2, -1, 0, 1, and 2. So for -2, we had -18.75, -7.5, -3, -1.2, and -0.48. So -18.75, -7.5, oops, -3. What was the other ones? -1.2 and -0.48. Okay, so this one would probably be better to use the graphing calculator for, because none of those are very clear. They're all kind of decimals, and you don't want to deal with all those decimals. So this would be a good one to use the graphing calculator for. Save some time. Okay, so -2, -18.75 won't even appear on the graph, so you don't have to worry about that. -1, 7.5, so that's 9, 8, 7, so 7.5 would be right here. 0, -3, 1, 2, 3. Okay, you got -1, -1.2, so just a little bit below 1.2, and then 2, -4.8, about right in the middle. Okay, so then you just connect the dots best you can. Okay, and it'll look something like that. Not as pretty as the graphing calculator, but you get the picture. So domain doesn't change. Still all real numbers, but the range does change because of that negative, and it reflects across the x-axis. Now all my y's, you notice, are negative. Okay, but it gets infinitely close to 0, but it still doesn't cross. So now my range is going to be y is less than 0, because all my numbers are less than 0. All my numbers are going to be negative. That number, the negative is going to keep getting smaller. It's going to keep getting closer to 0, but it's never going to quite cross it. And the asymptote still doesn't change, though. It's still x equals 0, because even though it flipped over the x-axis, it's still approaching that line of trying to cross the x-axis, but it never quite hits it. It approaches very closely, but never quite crosses it. Okay, so the asymptote, then the only thing that changes on that when they have a negative front and reflects it is the range. Okay, and you need to know that flips over the x-axis. Okay, translations. Same translations. If you have x minus h, remember it's always x minus h. Moves it left or right. Okay, I know it's always opposite. X minus number is going to move it to the right. X plus a number is going to move it to the left up here. And then plus k is always straightforward. If it's plus a number, it's going to move it up. If it's minus a number, it's going to move it down. Okay, this will change. The asymptote of an exponential function is a horizontal line. So the asymptote for an exponential function will be y equals k. So whatever your k is, that's going to be your asymptote. Okay, so we have this one, state graph each function, state domain range, state the asymptote. Again, a lot of stuff going on here. Probably going to use my graphing calculator. Okay, so let's plug that in. Try and get it so we can see everything. So let's go back to y equals, hit clear, and go 4 times 2 to the power. Now all of that is in the exponent. So make sure if your calculator doesn't do this, you either put this in parentheses or make sure it's all raised, because otherwise it won't work. But I'm going to put x minus 1, okay? And then I push over to make it go down. And then minus 3. Okay, so that's what it should look like. Again, your calculator, if it just has a caret, then you have to make sure x minus 1 is in parentheses. Otherwise, it won't work like this. Okay, so then I can look at my table, which is negative 2.5, negative 1, 1, 0, 2, 1, 4, 2, 8. Okay, we could have plugged these numbers in and got that. It's just, this is a little bit easier, a little bit quicker. So let's make that table. 0.5, 1, 2, 4, 8. Okay, so negative 2, negative 1, 0, 1, and 2. Okay, so that was 0.5, right? Try to remember. 0.5, 1, 2, 4, and 8. Okay, so negative 2.5 be right here. Negative 1, 1, 0, 2, 1, 4, 1, 2, 3, 4, and 2, 8. Did I do this right? Okay. It should look like that. Actually, I messed up. It didn't go all the way. This messed up right here. Okay. So we forgot the minus 3. Okay. So let's start back. Mistakes are part of math. Let's go back and fix our table. Knew that wasn't wrong, right? Because it should be, the asymptote should have been negative 3. It wasn't. So we made a mistake right there. So let's erase that and go. Let's see here. Okay, so you got negative 2.5, negative 2, negative 1, 1, and 5. So negative 2.5, negative 2, negative 1, 1, and 5. Okay, so negative 2, negative 2.5 would be about right here. Negative 1, 2, 0, negative 1, 1, 1, and 2, 5. Okay, so now you can see what the graph is supposed to look like. Okay, domain is still all real numbers. And the range, now the range changes. Notice how we said that will always be your asymptote is at negative 3. And you can see from here how it levels off at negative 3. Okay, so now our asymptote changes with that. So our range is going to change with that as well. Our range is going to be y is greater than negative 3 because all our y's are bigger than negative 3. Okay, and then our asymptote is going to be x equals negative 3. Okay, so that changes a lot when you add that add and subtract. You got to change your range and you got to change your asymptote. Okay. All right, let's see if we can do this right the first time on this one. We got, again, a lot going on. Probably going to put this in my graphing calculator. Okay, but you could do it without it. Okay, so let's do that. Let's go to Y1, hit clear, and let's go 3 parentheses 1 divided by 2. Let's go large screen. And then to the power of x plus 1. Okay, and go minus 2. Oops. All right, minus 2. Let's hit graph. And our isotope should be at -2, which you see it is right there is at -2. Okay. And everything else should be right. X plus 1 should move it to the left 1 is what that should do. And the 3 should make it a vertical stretch of 3. Okay. So let's see. Our table will be 4, 1, -0.5, -1.2, -1.625. Okay. So let's do that real quick. So it was at 4, 1, -0.5, -1.25, and -1.625. Okay, so when we graph that, we got -2, 4, 1, 2, 3, 4. Got -1, 1, 0, or -0.5. We got 1, -1.25, and 2, -1.625. So it'll be about right here. I know I got that line there, but that's fine. We'll fix that later. Okay, so then the line should look like this. Okay, and then it should go up like that from here. Okay, doesn't have to be perfect, just close. Okay, so then the domain doesn't change. Domain is always all real numbers on exponential functions. The range now, if you look at this number, should be y is greater than -2. Okay, because all the lines, it approaches -2, but it doesn't quite hit it. You got -1.25, -1.625. It's going to get close to -2, but never hit it. And you can see that from our dotted line. If we draw that dotted line across at -2, I think it's helpful to do that. Okay, it's going to infinitely put close that, but it's never going to quite hit it. Okay, so you're at x equals -2. Okay, so you got the domain range, where it's asymptote, and what the graph looks like. Okay. Okay, so that's pretty much it. The main thing. So how can you tell? We'll go back to the essential question. How do you find the asymptote of exponential function just by looking at it? You can just look at the k. Okay. On all the first ones, there is no k, so it's just x equals 0. Okay. X equals 0. X equals 0. But then when we add the k in, it shifted it. So when the k was -3, the asymptote was x equals -3. When k was -2, is x equals -2. So that's how you can tell what the asymptote is just by looking at the graph. So you should be able to do these pretty easily just by looking at the graph, tell you what the asymptote is. Okay, so put those notes and be ready to go for Friday. And that is it.